Hi friends, this is Soft Reason. Okay, so in the previous lesson we stop here. Okay, so this is the part 2 of the previous lesson. So if you are not in the part 1, kindly check the video so you can be able to start from where we start as you continue with us in this lesson. Okay, so in this lesson we will be running the analysis of this structure, okay, and design it as well, after which we will go to the foundation and then do the foundation design using strip foundation. Okay, so if you are new on this channel, subscribe so as to stay tuned for more lessons, for I do advanced lesson like this every week. Okay, so let's start. Alright, for the analysis we will go to the ROC design. Sorry, we go to the analysis tab and then we will select 3D building analysis. We will have to check our parameter. We will be using 120 kilonewton per meter square as our bearing capacity of the soil. We click on OK. We can change the title, but for the sake of time, click on OK. Alright, go to loadings and then generate loads. Okay, click on OK, and then you go to edit material. You check the columns. You are going to use this C20/C25. Okay, grade 410. So the rebar will be considering Y16 and 20 as well, 25. Okay, click on OK. For the beam we will be considering 16. Okay, we will be considering 20 and 25 also. Alright, so for the link we'll be using 8 and 10. Okay, then after which for our slab we will be so we will select area of reinforcement white wall for our slabs. Okay, alright, we'll go to the foundation and then we will use 12. We will use 16. Okay, then we closed. So after which we will go to the analysis tab. Okay, we have to check the structure. If there is any error, click on check and then we start. You notice we have number of errors 0. Okay, so we can now close it. Okay, and then we are going to design columns. We're going to design the beams and as well as the steel members design check. Okay, all right, so we will click on start. So building analysis completed successfully. Okay, so we click on okay. All right, and then we are going to close this. So we have successfully analyzed the structures. Okay, and I believe that all the members has been designed also successfully. Okay, so what we are going to do, let's check if actually the members has been designed. Let's check the columns. Okay, all right, you can see all our columns has been designed. Okay, the diameter of this column is 350. It is a circular columns. Okay, so you can see the Stipa. We have 6 y16s. Okay, inside of the columns. Okay, it is using the links y8. Okay, so you can also do your printing. You want to get the report printed here. Okay, I'll close this. Let's check the beam. Alright, you can see all the beams has been designed successfully as well. Okay, let's check on the iterative design. You can see 3y16 top bar. Okay, top bar, and 3y16 bottom bar. Okay, so click on okay. If you want to check the bending moment, you click here. You see the bending moment. Okay, all right, you can check the shear. Okay, and then you click on exit and okay. All right, for the steam member, we are going to come to this steel design and then we will be checking this steel get designed. Okay, click on it. So you can see this steel member has been designed. You can see it here. Material, we use this. Okay, S355 and class 1. Okay, so you can see the design statute is passed. Okay, all right, so you can check this point to give you the area. Okay, where you can, this is for the runs. Okay, the runs of the ladder. Okay, so this is where you can get your calculations detail. Okay, and then print your calculation for your steel. Okay, design. Okay, so click on okay. All right, so you can also check your steel columns. Okay, you can see these steel columns. Now this column is they are this angle iron that we use for the part of the ladder. Okay, we use angle iron, this one. Okay, so you can see they are all designed successfully. Okay, so it's this UK angle 90 by 90 by 7. Okay, all right, it's class 3 sections. Okay, so that is it. All right, so we click on the closed. All right, so all the members here has been designed successfully. Let's do the flat slab design. Okay, and so for us to be able to do that, we will go to the first story and I will navigate to the plan view. Okay, all right, so the first thing we need to do, we will have to draw strip. Okay, finite element strip. Okay, all right, and then we'll go to slab strips. Okay, then we select finite element. Okay, you go to the FE tab. All right, you activate this one. Okay, so once you activate this, what you need to do is you will click on this point, and then you will hold Control key to have a straight line. You click on this point. Once you click, you have something like this. Okay, the next thing you need to go to General tab. You can see the distance from this point to this point is 1 meter, which is 1000 mm. Okay, to the left and to the right. Okay, so we are going to increase it so it can extend to this point. Okay, so what we need to do is we are going to put it to be 3000. Let's see. All right, it's beyond. All right, okay, so we are going to reduce it to 2000. Okay, sorry, 2000. All right, let's make it 2200. Okay, 2100. All right, let's make it 2000. 2050. Okay, 2050. All right, so we will be working based on this. Okay, we'll do the same thing here. Okay, 2050. Okay, we update. Okay, it's beyond this way. Okay, say 1900. Okay, all right, we'll have something like this. This is in the direction X. Okay, so we'll also have to do the same thing in the direction Y. Okay, you click activate this direction Y. Okay, and then you click this point, you extend to this point, or your Control key to have a straight line, and then you click. All right, you still have something of this kind. Okay, so after you must have finished drawing your strips like this. Okay, you have to close that. All right, and then you will go to the analysis tab. The analysis tab, you will have to click on this FE floor analysis. Okay, then you click on it. Once you click on it, you have to remove this consider beam torsional stiffness. Okay, you remove it, we are not including that. Okay, all right, so you check this and this point, and then you can still edit material, but material has been edited before, so no need. Okay, and then you click on floor mesh and analysis. It's alright. It has taken us to this page. You have to zoom to be able to see the structure. Okay, so this is the flat slab. Okay, right, so you will have to mesh it, but I will want you to reduce the plate element size to 500. Okay, for ease of analysis. Okay, alright, so after which you click on this generate models. Alright, so model is being generated. So the next thing you have to do is to close this. It will now transfer you to the interface where you can run your designs. Okay, so it has taken us to the post analysis process and report. Okay, so what we need to do here is we will have to click on this analysis post processing. Okay, but by there you have to check this point, mesh column result with building analysis result. Okay, and then you click on this point. Alright, so you have to also zoom to bring in this structure. Okay, so these are the loads that we applied on this particular structure. Okay, these are the loads. Okay, so you just activate the contour. Okay, you can also use this user defined contour. Okay, all right, you can see the loads. So the next thing we have to do is, so after which we want to start an animation. Let's see the behavior of this. Okay, you can see the behavior of the flash slab in respect to the loadings. Okay, you can also increase it here as well. Increase it. Okay, all right, you can see the behavior of the flash slab, the deflections. Okay, all right, you can just stop this. Okay, so we want to start the design. Okay, we check the bending moment in the global axis. Okay, you can see the behavior. Okay, and then you check it in the y. Okay, and then in the xy. Okay, then the bending moment in the local axis. We also check it. You can see the values here. Okay, in kilonewton meter. Okay, so direction 2 and this. Okay, you also check this design moment. Okay, of the flash slab. Okay, so the required design area of steel, you check it. So we have an area of steel direction, area of steel direction 1 bottom. Okay, you are having the IS to be on 186. Okay, millimeter square. Okay, per meter. Direction 2 bottom, you have 257.83. Okay, so in the top, okay, direction 1, we have 321.72. Okay, so top direction 2, you're having this. Okay, so we have successfully run the design of this flash slab. Okay, so the next thing we need to do, if you want to check the bending moment and the shear force of this flash slab, what you need to do is you need to come to this point. Okay, you see this point, you click this point, it will show you the plan view of this. Okay, so once it shows you the plan view of this, what you need to do is you just click on these strips. Okay, you click on this point, drag it across. Okay, you can hold your control key as well to have a straight line. Okay, after which you release your hand. All right, so it has taken you. This is the behavior of the flash slab. You can see the moment. Okay, all right, you can also check the design moment. This is the design moment of it. Okay, all right, and then you require area of steel. All right, to reinforce this point, because you are going to reinforce it top and bottom. Okay, all right, you can also check the displacement. Okay, all right, then you close this. So after which you can see the design has been done successfully. You can also transfer your contour. You said export contour. Okay, click on this point to export this contour. So to get it back to your 3D, you just have to click on this one. You click on this one and then click here, then you zoom. Alright, so after which you just click on closed. Okay, it's asking you to transfer slab strips. Okay, so you click OK. Alright, so you just closed here. You closed. Okay, so after you closed, the next thing you need to do is you have to just right click. You have to just right click and then click on arrange Stipa. Okay, slab slate Stipa. Okay, you can see the slate Stipa for the flat flat slab has been generated. You can see white wave 150 top. Okay, white wave 150 top this way and also this way. Okay, bottom. Okay, this way is 250. Okay, so that is the Stipa generated for your flat air or your flat slab. Okay, so the flat slab has been designed successfully. Okay, so the next thing you need to do is you have to just save the project. Okay, so after saving the project, you can navigate to the story tree. Okay, if you navigate to the story tree, you see you have to draw strips for this particular slab. Okay, so you click on the slab strips. Okay, and we are now going to use the analytical strip. Okay, so we are going to choose bulb to bulb because it's outside to outside. Okay, so we'll start it in the X direction. Click this point. Okay, and then hold down your control key to have a straight line. Okay, and then you click. See, your strip has been inserted. Okay, you come to the direction Y. Okay, and then you do the same thing. Alright, so your strips for your slab, you can see this is the top bar. Okay, this is the top bar, then this one is the bottom bar. Okay, so all has been inserted successfully. Okay, so the design has been done successfully. If you navigate to the 3D view, you will be having something like this. Thing I would like us to go and design now is our foundations. Okay, and the foundation we will be using a strip foundations. Okay, and so before then we have to save the project. Okay, alright, so after saving the project, we will now navigate to story 0. Okay, we will navigate to story 0. Alright, so and then we'll go to the plan view. Alright, so we'll have to activate the beam. Okay, this beam we are going to use 450, our strip beam. Okay, we are going to use 450. Okay, 450 by okay, 350, sorry, 350 by 500. Okay, 350 by 500. Alright, alright, so we are going to insert this beam. Just like this. Okay, so after which we are going to start to insert our strip foundations. Okay, we're going to insert our strip foundation. If you click on this beam, you right click. Okay, you see insert straight footings. Okay, click on it. Okay, after which you click on loading design. Okay, after which you the footings depth here is 400. Okay, the footing depth is 400, and the cantilever that we guide against overturning is 1 meter, which is 1000 millimeter. Okay, so we'll select white wave. Okay, for our reinforcement. Okay, then we'll do the design and see if it will actually pass. Okay, so after which I want to change this footing depth to be 350. Okay, 350, just like this. Okay, and then we now in you can see the subgrade reactions coefficient. Okay, so click on the design. Alright, so that footing has been designed successfully. You can see the calculations the reports of the bend moment and the shear force. Okay, so the 14 has been designed successfully. You click on OK, and then you OK it again. So this is the 14. Okay, all right. So we want to do the same thing to this side. All right, you extract it. Okay, you change this plus to 350. Okay, leave the cantilever at 1000. Okay, so you just do what I'm doing. Okay, and then you design. Alright, this one too has been designed. If you want to print the report, you just click here, design report. Okay, will be printed for you. Okay, so click on OK. Alright, you do the same thing here. All have to be 360 and 12. Okay, and then you have to design. Okay, and then you click on design. All right, so you'll be having this. Okay, you'll be having this. All right, so we'll do the same thing this side. Okay, start 350 and you change here to white wolf. Make sure the loading design envelope is checked. Okay, so that you can use this loading combinations. Okay, this one, yeah, this one. Okay, all right, so you click on design. You OK and OK. All right, so the footing, the strip foundation has been designed successfully. Okay, so let's navigate to the 3D. Let's see what we have done so far in the 3D. You'll be having something like this, just like this. Okay, just like this. Okay, so this is your strip footing. Okay, all right, so the next thing you have to do, we want to send the project to the Prota detail. Okay, but by then you have to save this project. So after saving this project, okay, the next thing you have to do is you now have to come to the ROC detail. Okay, ROC detail, and you click on the Prota detail for the drawings. Okay, so the Prota detail is loaded successfully. You can see the concrete water stand. Okay, water tank stand. Okay, so the next thing, just click on auto generate. And then click on draw. You can pick any point on the drawing area. All right, so you can see this is your strip. Okay, strip foundations. Okay, these are the beams. Okay, at different levels. Okay, and then this is the columns point. Okay, I see the reinforcement diameter. Okay, at different level as well. We come to this part. This is the beams. Okay. Alright, so this is how you carry out your water stand design analysis. Okay, so these are your drawings. Alright, want to export it to AutoCAD, you can just click on this point, right click and then export it. Okay, it will take it to AutoCAD. Okay, and so that is it. I want to close this, so save this, I say yes. Okay, alright, so this brings us to the end of this lesson. Okay, if you have not subscribed, subscribe and stay tuned for the next advanced lesson. Okay, so bye for now.